So section 4.1 is our Hindu-Arabic system. That should be an M there. And early positional systems. Okay, part of this is going to be a little review of what you know about numbers. And then I'm going to expand into stuff that you probably don't know. And so first of all, knowing the difference between a number and a numeral. So a number is an abstract idea that addresses the question, how many? Okay, it's an amount. Whereas a numeral is a symbol used to represent that number. Now, you guys have used different numerals with maybe not even thinking about it, but you have used different numerals to represent the same number. So, for example, 25, this is our Hindu-Arabic numerals. We use a system called Hindu-Arabic. You might not have known that that's what our numerals are called. But maybe you guys were playing a game or playing cards or something and you were tallying up your points and you might have listed 25 this way. Okay, this is a different numeral system. Okay, where each little hash mark stands for one number, so 1, 2, 3, 4, and then cross it to make 5. The only purpose for crossing it is because it's a lot easier to count in groups of 5. And some of you may be somewhat familiar with Roman numerals, which this is how you would write the number 25 with Roman numerals. And we're going to talk about Roman numerals later in this chapter. So if you're not familiar with it, that's okay. We'll go through it. All right, so all of these represent the number 25, but there's 3 different numerals being used for that number, okay, so that you understand what's the difference between a number and a numeral. Now, looking at, okay, a system of numeration. This consists of a set of basic numerals and rules for combining them to represent numbers. We are going to be looking at various systems of numeration in this chapter. I've already sort of alluded to Roman numerals. We've got Hindu-Arabic numerals. We're going to talk about Mayan and Babylonian numerals today. We're also going to talk about the Egyptian numeral system where they used hieroglyphics. Okay, so this chapter is going to feel more like a history lesson than a math lesson. And don't be intimidated by what you don't know. Okay, we're always learning new things every day. There's going to be a pattern for each system that we talk about. Now, the reason we might want to look back at some of these ancient numerals is because it's the same reason why we take history class. We don't really know who we are until we've gone back to see where we came from. And so you don't fully understand our current system if you don't go back and look at, well, how did they start out with these numeration systems? You know, where do they come up with these things? And it shows you why we use what we use today. You'll be happy that we use what we use today because each time they got it a little bit better and got it a little more right. All right, so let's look at our Hindu-Arabic numerals. The reason they are called Hindu-Arabic numerals is because they were invented in India, where they practice Hinduism, and they were brought to Europe by the Arabs. Now, the Hindu-Arabic numerals only use 10 symbols. You might have thought that we had more symbols, but when you think about it, it's just 10 symbols that are used together in different arrangements. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we call them digits. Most of you guys know that, okay? So we've got 10 digits in this system. How we group these digits together tells us what number we are representing. All right, so this is the part that most of you guys are familiar with. If you see the numeral, okay, this number 12,657, represented by the numerals 1, 2, 6, 5, 7, then most of you know that this is your ones digit, your tens digit, your hundreds, your thousands, and your 10,000s. So notice that as we move from right to left, we're going up a multiple of 10. Okay, 1 times 10 is 10. 10 times 10 is 100. 10 times 10 times 10 is 10,000, 1,000, and so on, 10,000. So we're going up by multiples of 10. And notice that we use 10 symbols in this numeration system. So to determine the number represented here, it's based on what position the values are in, these digits are in. So I know to say that it's 12,657 because that 2 is in the thousand spot. So I said 12,000, and then the 6 is in the hundred spot, 657. That's how I know to read it because of the position that those numbers are in. So one way to determine the value is to write it in expanded form. And this is probably something you're not as used to doing. Expanded form is a way to write a numeral in which the value of the digit in each position is made clear with the use of exponents. So looking at that 12,657, how many ones do I have in the number? 7. How many tens? 5. 5 tens, that's how I knew it was 50, right? 5 tens. How many hundreds do I have? 6 hundreds. Okay, so I could write it out like this, where I have a 7 plus a 50 plus 600 plus 2,000 plus 1 10,000 So while background music is nice, let's make sure our phones are turned off. So notice that if I add a 7 and a 50 and a 600, right, because I had 600s. If I add all of these together, it gives me 12,657. I've expanded it somewhat, but it's not made, using the exponents. So I could instead note this as 7 times 1, 5 times 10, 6 times 100 based on the place value it's in, right? So I can multiply it times that place value. So I can also write 12,657 this way. So I have a 1 times its place value, plus 2 times its place value of 1,000, plus 6 times its place value, 5 times its place value, and 7 times its place value. But also think about that we have been practicing with number theory and how I can write numbers with a base and an exponent. So the 10 is just 10 to the first, right? But I can write 100 as 10 to the second. I can write 1,000 as 10 to the third, 10,000 as 10 to the fourth. Notice that the number of zeros actually even tells me what the exponent is, right? 2 zeros means an exponent of 2. 3 zeros is an exponent of 3, and so on. So here's how it truly is in expanded form. I have a 1 times 10 to the fourth power, plus 2 times 10 to the third power, plus 6 times 10 squared, plus 5 times 10 to the first. And then in this book, they leave it as just a 1, 7 times 1. Technically, though, that would be 10 to the 0, right? Because what is 10 to the 0 equal to? 1. Okay, so in the textbook, they leave it as a 1, but you could have written it as 10 to the 0, and it would be in that same format. So this is how we write 12,657 in expanded form. All right, so because of how our numbers work, okay, because the place value tells you what you are multiplying it by, then this is called a positional value or a place value system. Not every numeration system is positional, but ours is. Positional value or place value system, a system in which the position of the digit determines its value. All right, so go ahead and practice on your own putting these into expanded form. So we'll start with 4026, and in a second I'll move it up and there'll be another one. Okay, so the second number is 24,232. Okay, so with 4026, well, we know that we have 4 times, it's really 4 times 1,000, but with exponents that would be 10 to the third power, because 1,000 has 3 zeros in it. Then plus 0 times 100, which is 10 squared to the second, plus 2 times 10 to the what? To the first, because that's our tens digit, plus 6 times 1, because that's our ones digit. Okay, good question. Do we have to do the 0? Technically, no. We don't have to do the 0. And I was trying to look for a problem that had a 0 in it, but I couldn't. I wanted to just try it out. I'm pretty sure they don't want you to type the 0. And so because you're just adding 0, right? And adding 0 doesn't change your value. So you can drop the ones that have a 0 in it. But I did notice that when they show it in expanded form for other problems, they have the 0 in there. So you want to experiment and see if it really wants you to type the 0 or not. I'm okay with you dropping the 0. So I'm okay with either because they're both correct. This one's more simplified. But because the book is not consistent, I'm not going to keep you to that. All right, so for the next one, we need a 2 times what? Okay, 10 to the fourth. Now notice as the numbers get bigger, you sort of have to think about it. How many zeros do I have here? And let me give you a little tip that might help. Your ones digit is your 0 power, right? Your ones, and it also starts with an O, right? The number 1 starts with an O. So that's your 0 power one. Then the next one would be 1. A tens digit is 10 to the first. 100 is 10 squared. 1,000 is 10 cubed, and so on. So you could always just list the little degrees above the digit as you go. It should start with 0 on the right and then go up to the left that way. So if that helps you to sort of visualize it without accidentally writing the wrong exponent. So then we've got plus 4 times 10 to the third, plus 2 times 10 squared, plus 3 times 10 to the first, and then I ran out of space here, plus 2 times 1, our ones digit. Now, I've also mentioning this now when it's a little easier because we're working with our Hindu-Arabic system. We're going to have some that have other numbers, and writing these little exponents might help when we get to those other types of numbers. All right, so this is writing it in expanded form. Any questions on how we do that? So then you're also going to have to go in the other direction and express each expanded form as a Hindu-Arabic numeral. And I got a little typo here. This should be a plus sign. But in other words, they want you to take 6 times 10 to the third plus 7 times 10 to the first plus 3 times 1, and they want you to multiply it all out and add it together to figure out what numeral is that actually representing. And again, the process could be different for each of you. It's however you want to work it out. But you might want to figure out, okay, so 10 to the third is the same as 1,000, so this is 6 times 1,000. And then we know 7 times 10 is 70. 3 times 1 is 3. Okay, if you want to break it down one piece at a time, then that's fine. So this means we have 6,000 plus 70 plus 3. And so altogether we have 6,073. So go ahead and work this one out. You have 8 times 10 to the fourth plus 9 times 10 squared. All right, so this is the same as 8 times 10, or a 1 with 4 zeros after it, right? 10,000. and this is a 9 times a 1 with 2 zeros after it. So in other words, we have 80,000 plus 900, which gives us 80,900. Okay, everybody good with expanding and bringing it back as a single numeral? All right, so the purpose for why we went through this is because knowing how the Hindu-Arabic system works, this is the one you're most comfortable with and most familiar with. Knowing how it expands and comes back together is going to help with the other numeration systems. We're only going to talk about one more today. We'll save the last one in 4.1 for next time. But we're going to look at the Babylonian numeration system. Now, before I move on, again, I sort of mentioned this, but notice we're using powers of 10, right? As we move from the right to the left, it increased another multiple of 10. So we had ones, tens, hundreds, and so on. So the Babylonian numeration system is also a positional system using powers of 60. How many different symbols do you guys see? Distinct symbols. Okay, Patricia, you see 2. Okay, good, you see 2. There are 2 different symbols that are used in the Babylonian numeration system. These are like their digits. Where we have 10 digits, Babylonians only use 2. Okay, so it's a sideways chevron. If you guys didn't know that's what that shape is called, a chevron, or a chevron that opens up. Okay, you guys, most of you will say it's a V and a sideways V. Okay, but do you see how we've got like 3 symbols sort of grouped together and then some space, and then another 3 symbols grouped together and then some space, and so on? This is how they determine what position they're in. So instead of just ones, tens, hundreds, and so on, where like they're right next to each other, you had to put some space in between it to show that you're going to another place value. So just like the one furthest to the right for us is the ones digit, that is the same exact thing for the Babylonians. So the one furthest to the right is your ones digit, but then it goes up by 60. So here's our ones. Here's the 60 digit, and then 60 squared, 60 cubed, and so on. If it kept going, you would increase the exponent. So that's the place value it's in. So instead of the ones, tens, hundreds, thousands, we have the ones, 60, 3600s, and so on. Okay, we don't call it that, but 1, 60, 60 squared, 60 cubed. All right, so so I mentioned this here. They left a space to distinguish the various place values. So now we have to understand what these chevrons equal in order to determine what value this is. So the one that opens up is equivalent to the number 1. The one that opens to the side is equivalent to the number 10. Now we're actually going to determine the value of this numeral right here. And it's going to be really similar to what we just did with the Hindu-Arabic numerals. All right, so knowing the place values and knowing that this is a 1 and this is a 10. So here's how the homework problem might say, write this as a Hindu-Arabic numeral. Or it'll say, write the Babylonian numeral as a Hindu-Arabic numeral. All right, so step 1. Determine the value in each grouping. Okay, determine the value in each grouping. So remember that this equals a 1 and this equals a 10. So when we look at this, well, and it doesn't matter which side you start with. If I start on the left and I've got 2 of these sideways symbols, how much is that worth? 20, because I've got a 10 right? I got a 10 plus a 10, okay? You're just sort of accumulating all those symbols together. So a 10 plus a 10 gives you a 20. So we have a 20 here. So how much is in the next group? Say again? 20. Yeah, also 20. I heard something different. Okay, sorry. Yeah, we also have a 20 here. Okay, how about this third grouping? 12 is correct because we have a 10 plus a 1 plus a 1. Okay, so we have 12 altogether here. And then another 12 because it's the same set of symbols. Okay, any difficulty figuring out how much was in each grouping? Okay, then we are going to use expanded form to write the amount with exponents. Okay, I'm going to abbreviate exponents there, EXP. All right, so what's the place value of the one on the right? A 1. Okay, so this is a place value of 1. What's the next one? 60. Okay, so our system is based on 10s. This one's on 60. So 1, 60. Then the next one would be 60 squared, and the next one, 60 cubed. So now for step 2, I'm going to write this in expanded form. I have 20 times its place value of 60 cubed. Plus, I have another 20 times its place value of 60 squared. Plus, I have a 12 times its place value of 60. And then lastly, I have another 12 times its place value of 1. So we have just written it in expanded form. And then step 3 is to simplify using order of operations. Okay, so you want to multiply this out, multiply each amount out, and then add it together. So, real quick, I know we're coming to the end here. And again, if you have a good calculator with parentheses and the exponent key, you can type this in all at once. But we would have 20 times 216,000 plus 20 times 3,600 plus 12 times 60 plus 12. Multiply further. And we've got 432 with 4 zeros after it. And then 72,700 plus 12. Oops, sorry, this should be 720, not 700. And then you just add these all together. So we get 4,392,732. Okay, so that's the process for each one. There's a couple in your homework. You need to move to My Math Lab homework 4.1. You can stop at number 19 for now because we have not gotten to the Mayan numerals. So the rest of it is Mayan. So again, homework for Monday and Tuesday is 4.1, 1 through 19.